Okay, Algebra 2 skills number 26, rational equations. So what exactly is a rational equation? A rational equation is when you have a rational expression equal to another rational expression. So pretty simple. Rational, of course, looking like a big fraction full of variables is a very informal way of putting that. First example, sometimes you have where it's only one fraction per side or one rational expression per side. Typically, the way this is dealt with is to cross multiply, like a proportion. So notice I did the cross products here. I've got these corners in red, and I've got these corners in blue. You simply multiply those and set them equal to each other. So 15 times 3x plus 5 equals 29 times 2x minus 1. Sometimes people have a mistake here. They'll know to cross multiply, but they're not sure what to do with it. They'll keep it a fraction somehow or do different things. But you set those cross products equal to each other. So let's finish this problem. Of course, you would want to pause if you need more time to think about it. But this is the same problem, just not color-coded. We're going to distribute the 15 and distribute the 29. We're going to move the 45x over here to make it 13x, add the 29 here to make it 104. Of course, you might make that as two separate steps. Then simply divide by 13 to get 8. A second example, which looks a little more complicated because we have three fractions or three rational expressions. So cross multiplying would not work here unless you combine these, but it's generally better to do something different here. What we want to do is multiply. So here's the same problem. We want to multiply, or actually we factored right there. From here to here we factored. Same problem, but we got to factor so that we can figure out what the LCD is. So the LCD consists, if you remember, of every unique factor you see along the bottom. So if I look through here, I've got an x plus 5, I've got an x minus 7, and then the same 2 over here. And as long as one of those doesn't show up twice in the same fraction, I don't need it twice. I only need it once. Because my goal here, instead of cross multiplying, is I want to cancel out all the bottoms. So notice what I multiplied in red here. I just took these same three fractions and I multiplied them all by this x plus 5 times x minus 7. That's called the LCD. And what the LCD effectively does, it cancels each denominator. Okay, I need an x plus 5 and an x minus 7 to be able to cancel every denominator. Let's see how that works here. And by the way, it's perfectly legal to multiply as long as we do it to both sides of the equation. So I've changed my color coding here. It's the same problem, it's just different colors. Notice that the x plus 5 cancels, the x minus 7 cancels, and then here they both cancel. And that leaves behind a much more pleasant equation, which is easier to solve. Okay, the denominators are all gone. I distribute. Just be careful that negative 5. Combine like terms, 9x minus x, negative 63 minus 68. Add 68 to both sides and finally divide to get 11. A third example, it's not rare to see some quadratic equations come out of this. Let's take a look at that. So think about what your LCD is here. Your LCD would be x and x plus 8. Remember, it's not sufficient to say, well, I've already got the x, I just need to do a plus 8 right here or something. It doesn't work that way. This is a free x, this is an x that's attached with addition to their two separate fractions. So I need an independent x and an x plus 8. And as long as I multiply all three fractions, so in yellow is the same problem, and red's the new thing. As long as I multiply all three fractions by the same thing, it's legal. And that allows me, again, changing the color coding, you see it all together here. These x's cancel, the x plus 8's cancel, the x plus 8's cancel. And the idea here is that I no longer have denominators. Now a problem that was caused here, this is the same last line, is this is quadratic. We have this x times x right here. So that's going to cause us to have to work a little harder to get our answer. Distribute. Okay, so a lot happened from here to here. What I did was I subtracted 17x from the 3 to get negative 14x, and I rearranged the terms a little bit. Okay, but it is quadratic, the highest power is 2, so isolating x is not going to be sufficient. So I need to factor, and then set each factor equal to 0. Okay, so that does happen some. You do also need to look out for extra solutions or extraneous solutions which make the bottom 0, so watch out for those. Those sometimes happen. But either cross multiplying or the LCD, that's rational equations.